Okay, Assalamu alaikum students. Today we will study the implementation of the method we have studied earlier in the last week lecture, and that is bisection method. So today we will apply, I told you the MATLAB basic commands and how to use the commands. So today we will implement the bisection method in MATLAB. So first of all, what you have to do, you have to open the MATLAB. Just go to start and then search out for MATLAB and click it, and it will get some time to open. And what you have to do, you have to go to the new script. So in the editor window, you just have to type the editor in the editor window. So you have to click the new script and it will open the new editor window, and then you start typing it. So first of all, you know the basic concepts of the bisection method, and we declared the function for the bisection method. Okay. But the declaration of the function is of the bisection method is function square brackets. Anything you write along with the function with the square brackets, within the square brackets is the output. So what you need to find out is you want the root of the function. So the root must be f of, sorry, not f, it is basically root. Let's say it is the output is r. So that is output equals to whatever you want to name it. You can name by your own self. I name it as a bisection method. I told you it is a case sensitive, so always declare, whatever you declare the name, you just have to save with the .m extension file. Then if it is capital, use the capital alphabets, and if it is small, use the small alphabets respectively. So this is the name I have named it like bisection, and then use the round brackets. Round brackets is for the whatever you want to input the things in the input the stuff in this. So in the question, basically the things were given, like function was given, non-linear function was given, starting point was given in the domain, end point was given in the domain, and in this we will study if you input the iterations, then it will display the result, and in the next you have to do it by your own self, that how many iterations are required for the root. Okay, so we use n number of iterations as the input here, and EPS is for tolerance. So these things were given in the question. Okay, so F, A, B, number of iterations, and tolerance. Okay, so how to write the function? So the command for writing the function is the inline command, and then you have to use the round brackets, and then you have to use the single inverted comma, and whatever you are writing here becomes in the purple color. It is highlighted in the purple color, just to show that it is a correct function. So here we write the function round brackets, comma. So your assignment question was x square minus sine of x minus 0.5. So write it as x square minus sine of x minus 0.5. So your calculations will be in radians in MATLAB too. Use the semicolon. Okay, don't use the semicolon in the declaration of the function. In the first step, in the first statement, don't ever write that semicolon. Okay, in the function, in the input, you can apply, so that it suppresses the output and it will not display at the end of that. Okay. So f is equal to inline this thing. Okay, your domain is a is equal to 0, suppress the output, so use the semicolon, and domain was also given b equals to 2 semicolon, and let's say the number of iterations is 15. So you can also change the iterations, number of iterations, but if you have you have used it manually, then you have a rough sketch out that it will converge between 15 to 20 iterations. So I named it as I gave it 15 iterations. And the tolerance by default MATLAB use the tolerance. If you don't apply the tolerance here, it doesn't matter, because because it by default it calculates with up to 4 decimal places, and if you use the format long, then it will display up to 16 decimal places. So if you don't use the tolerance, it's okay. Okay, the first condition is if a is the root, then it means f of a equals to 0. So here if condition applies, that if f of a is exactly equals to 0. So the purpose of double equal sign means one is for assignment and the other is for equal sign. So if f of a is equal to 0, use the round brackets here, syntax, that is syntax, then a is the r. R is equal to a is assigned as r. A is the output, a is the root. Okay, and semicolon and return. So return, what does return do? Return don't a return command doesn't continue to the next steps, it just displays the output. If not, then else if. Else if is used, that if the previous if is not true, then use this else if. So else if f of b is equal to 0, then b is the root, so r is equal to b, and then return. So if not, then if a is not the root, b is not the root, else if, then come to the next point. Then we are moving towards the midpoint things. So check that you can apply here the bisection method or not. Right now we haven't applied the bisection theme here. So first condition for applying the bisection method is the intermediate value theorem, and before that it is the condition for the root convergence, and that is if function values are of opposite signs. So here we use the logic in the mathematical form. In the lecture, manually we just apply the values and check that whether it is of opposite signs, then it means it is the root lies in this interval. But here in the MATLAB we use something mathematically, and we use the techniques if the function values have the opposite signs. So that means if it has the same signs, then bisection method cannot be applied here. So else if f of a, we use the logic here, f of a into f of b is greater than 0, then it means display the error that f of a and f of b do not have opposite signs, or whatever you write here, method failed. You cannot apply bisection method here, so you can write anything between these, single inverted comma, in fprintf or error, end. Okay, the logic here, f of a into f of b is greater than 0, means that either both have the positive signs, then it is greater than 0, or both have the negative signs, then it is also 0. So the product of f of a and f of b, if they have same signs, like if both of them have negative sign, then it means it becomes positive, so it is greater than 0. The number is greater than 0, and if it is has both have positive signs, then it also product is also greater than 0. So that means same sign, so bisection method is failed here. Okay, then and all the ifs here. Okay, so these are basically the check conditions for or not. Okay, now come to the bisection method. If f of a and f of b is less than 0, that means opposite signs, one is positive, one is negative, the result product is negative, then we will proceed towards the bisection method. So this is the speciality of bisection method. Okay, for I equals to 1 to n, I runs from 1 to number of iterations. If I say that 15, then it runs 15 times, it displays the output 15 times. For I equals to 1 to n, let's see is the midpoint here. You can also write it p as the midpoint here. Let's see is equal to a plus b divided by 2. So that is the midpoint. P is here, the midpoint here. So a plus b divided by 2 is the midpoint. And if I take the value f of c is equal to 0, then c is the root. So r equals to c, return, semicolon, and this is the root. Root will be displayed here. If not, if it is not, then just carry on the iteration. And else if, now check that next step, if it is not the root exactly not equals to 0, then it means C is midpoint have to replace either A or B. So this is the condition here. You can also compare with the same sign conditions, you can also compare with the opposite sign conditions. So the bisection technique is that the midpoint replaces the same signs thing. Okay, so you can also use that technique. Just compare it with one of the function values. So if I compare with the other value function, then I can write it. So else if f of c into f of a is less than 0, it means it is of opposite sign, then c will replace b, because c is f of c and f of b will be of same signs. So f of c into f of a, if it is less than 0, that means one is positive, one is negative, then c will replace b, b equals to c. Else if not, then c will replace a. So this is very simple thing, very simple condition here. Else c will replace a. If it is not true, C is not if C, A and C, f of A and f of C does not have the opposite signs, then it means they have same signs, so C will replace A and B will be as mentioned before. Okay, so if f of c into f of a, you can compare it with f of b, is less than 0, then that means c and a are of opposite sign, function values are of opposite sign, then c will replace b, so b equals to c. Else if not, then C will replace A. So now the next steps are for the error convergence or relative error comparison, that will give you the accurate root and the stopping criteria of the bisection method. And that is if B minus A divided by 2 is less than epsilon. Epsilon is the tolerance. And if absolute of f of a is less than absolute of f of b, so basically this is comparison is just for a must be less number, to make it in the sequential or pattern that a is always the smaller number and b is always the larger number, and the selection of r and replacement of r according to a and b must be in the smaller and bigger term. So absolute of f of a and f must be less than absolute of f of b, and absolute of f of a is less than epsilon, that r is equal to a. Return else if absolute of f of b is less than epsilon, then r is equal to b. So returns that, gives you the accurate answer that meets the error convergence. In the programming, I tried it to skip this step, error convergence, but it doesn't give the final accurate answer according to my MATLAB. So you have to follow these steps, and then it will give you the accurate solution and accurate root for the given nonlinear equation. Okay. But how many ifs you have written within the for loop is 1, 2, and okay, only 2 ifs. So use 2 ends for that, and also MATLAB will show your ends. Okay, and also 1 end for loop. Okay, and one more end for the function declaration, basically the complete function bisection method. Okay, so this is all about the bisection method, and it will display, I think it will display the root x square minus sine of x minus 0.5 is, I guess, 1.1963. That is the root, and you get the root between 13 to 14 iteration. I don't know. Just have to save it now. If it runs correctly without any errors will show side by side, and you can clear out the errors by your own self. You save it bisection. So control plus s dot m. So dot m is the default extension for this. So save it by, if I declare it by bisection, then I save it by bisection,